Hello and welcome back to the lecture of time series econometrics. We have been discussing about different forecasting techniques. In this lecture, we are particularly going to talk about specific forecasting technique which is quite popular and that is known as exponential smoothing. Now, exponential smoothing is one particular topic of weighted moving average method. In case of weighted moving average method, what we have been doing was we're assigning weights to different observation as per our discretion. But in the case of exponential smoothing, we are assuming that the weights are decreasing from the present to the past period exponentially. So how we have so let us look at the evolution of different models that we have been talking about. So initially we started with simple moving average, then we spoke about weighted moving average method, and now we are talking about a very specific type of weighted moving average method, which is exponential smoothing. So here again, like the assumptions that we have been making so far in case of simple average moving average or weighted moving average method are going to hold true. That is, we are assuming that the time series that we have in our hand is stationary and the data doesn't have any trend or any seasonality. And we are actually going to plot the data without identifying the model, without actually estimating the parameters, and it basically the specific thing about this simple exponential smoothing, or you sometimes call it SES, is that this is we don't have seasonality and trend, so data will have only two components. One is level and the other is the noise. You remember when we spoke about the different components of a time series model, we spoke about these four components, and now we don't have in case of exponential smoothing, we are simply assuming out the level and the trend and the seasonality. Now, the most basic form of exponential smoothing equation. So, how we actually estimate that? We actually estimate that, um, like updating the level. So, it's a process of adaptive learning, and that we're going to see how this adaptive learning happens. So we at the basis of it, like the first equation that we can write is that we can say that if I am going to predict, say the forecast of t plus 1th period is equal to level of tth period. Okay, so let's say that's my equation 1. Now, if we actually use the past period values and the past period levels, we will see how this adaptation is happening. So here we will talk about two more things. One is that the constant term in the exponential smoothing, we sometimes call smoothing constant. Smoothing constant, we normally represent it as alpha. And then we have an important concept that is called level updating equation. Okay, so this level updating equation will tell us how this adaptive learning is happening. All right. So we let us expand this concept of level updating equation, and the equation is going to be like this. Say this is my level at period t, and it will depend on the level of period t minus 1. So I will estimate the level of t minus 1th period, and that level is going to sort of influence my present period level, and there is a deviation of the present period value. So let's say yt is the observation of the present period value, and so there is a deviation due to yt, and this deviation is from level of t minus 1th period. So this is the deviation component, and now I multiply the deviation component with the smoothing constant. Okay, so it essentially means my present period level, estimated present period level, is a sum total of the past period level plus the deviation that has occurred due to the present period observation, and I estimate this by subtracting the present period observation um, with the level of the past period, and I have a smoothing constant that I sort of adjust the deviation into my present period level estimation. So this is, let's say this is my equation 2, and I had my equation 1. So if I look this equation 1 and 2 together, so it would mean this is my forecast of t plus 1th period. So if I want to basically my forecast my t plus 1th period value, that is nothing but the level of the present period, the tth period. Okay. All right. So now let me expand this equation and let me actually bring the concept of exponent. How really the weights are decreasing with the as we sort of go for higher order values. Okay. So let us write down. Let us write down. So let us actually. So use this equation two, and let us sort of reorganize the equation two here a bit. So it means so I can write LT is equal to alpha YT, and then I can take 1 minus alpha L T minus 1, right? So this is how I can reorganize this equation. Let's write this is my equation 3. Now let's have another, um, like let's just go one period back and let's write down LT minus 1. So instead of LT, I am now estimating LT minus 1. I'm just substituting this T minus 1 value. So it will be in my series, if I just plot it, it will be yt minus 1 and lt minus 2, right? So let us write down this is my equation 4, and let us again reorganize this equation. So what I'll get is alpha yt minus 1 and 1 minus alpha lt minus 2. So this is my equation 5, let's say. Now, what I'm going to do is I'm going to actually use this equation 3 and equation 5. Okay. So what I'm going to do is I'm actually going to substitute LT minus 1 in equation 3 with the value of LT minus 1 that I just got in equation 5. So let us do that. So what I'm going to write is LT is equal to what I found in equation 3 is alpha YT, and then I had 1 minus alpha LT minus 1, which I'm going to substitute with the whole thing from equation 5, alpha YT minus 1 plus 1 minus alpha LT minus 2, okay? And if I just do this little bit of manipulation, what I'll get is this alpha into 1 minus alpha YT minus 1, and then I will get 1 minus alpha whole square LT minus 2. So this is my equation 6. Now take a look at this. So essentially what is happening is uh, when we are substituting this way, so the weights of the past period values are declining, right? So because alpha, the value of alpha is between 0 to 1, okay? So it's between 0 to 1. It can also take the value of 0 and 1. So since it is between 0 to 1, uh, we will have these past period values, the corresponding weights are going to be declining, right? And as we sort of keep on substituting L2 minus 3 with LT minus L2 minus 2 with LT minus 3 and so on, we are going to get higher order YT values, right? And that is why we will see the past period values are going to decline as we keep on adding more and more terms this way, right? Okay. So one more point, just note the difference between the previous simple moving average or weighted moving average. We're actually defining the window size. But whereas in case of exponential smoothing, we don't have the provision of defining the window size because it's exponential process, right? So I really don't need to specify any window size. Okay. Um, so if I have now let's deal a little bit with alpha. So if I have a low alpha, it would mean that it is actually learning very slowly. Okay, so it is gradually learning. Okay, whereas a high alpha would mean it is learning very fast. So a low alpha means it is going to take a lot of past period values because it's slowly learning. Whereas a high alpha means the present period value would have a lot of the recent period value will have a lot of influence on it. So in general, if I have a low alpha, it's the series is going to look like more sort of smooth, whereas a high alpha is likely to give us more sort of impulsive series where we'll have a lot of zigzags. Exactly the same way we have seen for simple moving average or weighted moving average. So in general, we tend to prefer alpha value a little low. So in general, it is the alpha value is like zero point 0.2 or zero point 0.3. That is what we take. So there could be extreme cases of the alpha value. I mean, it is absolutely up to you to choose alpha value. For example, let's take alpha equal to 0. Okay, so if alpha equal to 0, from equation 4, we can see that the whole term is becoming, it has no role in my LT minus 1, in determining LT minus 1, or the same way basically from equation 3, or equation 2, if I write alpha equal to 0, so my LT is nothing but my LT minus 1. So basically my present period level is nothing but my past period level. If so, that means I'm not at all, incorporating my past period value. Whereas I can also have alpha equal to 1, in which case you are actually giving a lot of importance to the deviation that has happened because of yt, right? So that means I'm actually giving a lot of value to what happened to my past period observation. So depending on what kind of time series you are, like depending on the nature of data and what you understand from the data, you can decide on the value of alpha. All right, and then I will show you a small example. Okay, let me give an example to where you can have a value of alpha equal to say, alpha equal to say 0, and a value of alpha equal to say 1. Okay, so a good example of alpha equal to 0, for example, for government employees, okay, where you might get some DA or bonus or something, but you really don't have a salary hike. It depends only on some pay commission, revision. So in those cases, alpha is going to be 0. So even if you have a little bit of fluctuation here and there in the past period, it really doesn't count, right? Um, so that might be a good example of alpha equal to 0. Okay, and where alpha equal to 1, say for example, if you have seen like the street fights happening, okay, so the champion is determined solely based on the fight outcome that happened in the last fight. Okay, so if you lose, if you win in the last fight, you're the champion, and the day you lose in the fight, you are nowhere, nobody knows you. Okay, so that way, if you have seen like the rapper competitions, I don't know if you like Eminem, but if you've seen his movies, like in rapper competition, if you are champion in one night, so you're the hero. If you lose it, you're gone. So in those cases, you can write say alpha equal to 1, but these are like very extreme cases. Okay, so let's say street fight or rapper competition or something like that. Okay? So these kind of cases, you can have alpha equal to 1. Okay. Now, anything else I need to show you? Probably I can show you an example of how do we do that. Let me see if I have an example ready for you. Okay, suppose let's give an example. Suppose looking at this equation, I can write it here itself. Say I am going to predict the, say this is November 2020, and I'm going to predict something about say December 2020. And what I'm going to predict, say let's say say price of potato. Okay, let's say price of potato. That's what I'm going to predict. And how do I do that? So, just to make sense of these equations, so I will actually, so December 2021, that's December 2020, that's going to be my forecast value, forecast December 2020, which is according to my equation is equal to level of November 2020, right? And so level of November 2020 would mean, level of November 2020 would mean level of October, say 2020, level of October 2020 plus alpha into my observation, my real price of potato, price of potato, price in November, price say November 2020, okay, actual price, let's write actual price in November 2020 minus my this level of October, level that we see in October 2020. Okay, so that way we can estimate the level in or the forecast the price of potato in December 2020. So in general, what happens is you can basically calculate the levels, this level of November 2020 or level October 2020 based on past period values that you have in your hand, because you are just predicting the next period. So you have all the past data available with you, and you can basically predict the forecast using exponential smoothing.